All right, so this is the Unit 7 test review. So we got to find out which of these are third degree binomials. And then we have to select all that apply. So we're picking everything that's a third degree binomial. So the first thing we see is third degree. So this means that we want the highest degree to be 3. So if I look, I see I've got a 4 here, so that's too much. So we're not going to pick that one. So we're going to go ahead and get rid of C. That's a 3, but remember, this is x to the 1. So 1 plus 3, that's actually a total of 4. So you have to get rid of A also. If we look at this one, we've got 2 plus 1 for our exponents equals 3. Remember, we get to ignore the coefficients. 1 plus 1, now you might think that doesn't work because that's only 2. But remember, for degree, it's only the highest degree. So we can ignore anything that's lower than 3. It really just doesn't count. Over here, I got 1 plus 1 for 2. And then 1 plus 2 will give 3. Again, up here, this didn't work. Not only is this a 4, but we would do 3 plus 4 is 7. And 7 is way too big. It's bigger than 3. And then this is kind of the trick one here because it's got the 3 there, but it doesn't work out. So it's between B and D, and I could pick both of them. It says select all that apply. But here now I need to have binomials. So remember, a binomial is going to be 2 terms. And the way we separate terms is with either a plus or a minus sign. So this one would have, oops, I don't put my line there. This one would have 1, 2, 3 terms, even though we already got rid of that. Just to review what terms means, that one has 3 terms, whereas this one here has 2 terms. So this one's okay for the green, but it's already out for the blue. This one would have been out for the green. Here with the plus sign, I can see I've got 2 terms. And binomial means 2, so I'm going to pick B. Over here, also I've got 2 terms. So we're good to go for D as well. So looks like we got B and D. Just as a quick review for the vocab that we did, if we had 1 term, remember that'd be like a monocle, it's a monomial. If we have 2 terms, binomial, so we already have that one. We have bi for binomial, or bi like a bicycle, we said in class. And then 3 terms is a tricycle or a trinomial. Anything more, we didn't really talk about too much. Again, there are quadnomials, quinomials, but we're just going to stick with these 3. These are the 3 that we were learning about. Anything more than this, we just called polynomial. We just said was a lot of terms. All right, for number 2, we need to write this in standard form. So you have to remember that the rules of standard form are the exponents need to go in decreasing order. So if I look, I want to find out which one's got the highest exponent. So if I look at my exponents, we got a 3. Remember, that's a 1. That's a 4. This is a 0 because there's no x's. So this one's going to go last. I know that one's at the end. And then that one's got a 2. So if I see which one's the biggest, 4 is the biggest. So I'm going to make that one go first because 4 is the largest. So this one gets to go first because 4 is the biggest. Then the next one I'm going to pick is going to be the 3 as the exponent. So plus 3x3. So that one's going to be next. Then I got 2 is going to be next. This one's going to be third. And this one I got to be careful with because it's a minus x squared. I have to remember to keep the minus sign with the x squared. Fourth would be just the one with the 1. So this one's going to be fourth. And again, this one's got a minus sign. So I'm going to do minus 5x. And we know the number has to go last, and the number also has a minus sign, so we have to have the minus sign with the number as well. And that's it. There's no actual calculations. It's just rewriting it and analyzing what the expression looks like. All right, for number 3, simplify and then write the answer in standard form. So we're going to add everything up. When we're adding, we can just ignore all the parentheses. We just look for like terms, and we're going to combine like terms. So 3x to the 3's plus 4x to the 3's is 7x to the 3's, so 7x cubed. X squared should come next because we want to do standard form. So I see right there I've got minus 9x squareds plus no other x squared, so 0 plus negative 9 is negative 9. Just single x's are going to come next. So I've got 7 plus negative 11. 7 plus negative 11 is going to be negative 4, so minus 4x. And then negative 1 plus 1 is going to be 0. Now, I don't need to write the 0 if I don't want to. Again, so I could put plus 0. I don't have to. It's an option, but that's because I've got negative 1 plus 1. I guess I'll put the black over here. 3. I did 3 plus 4 to get 7 as my coefficient right here. And that's it. We're all set. Same deal with number 4. This time, though, we just have a subtraction. So there's one step we got to do before we want to do anything. Some people were sort of subtracting in their heads when we did them in class, and that's totally fine too. But mathematically, if we want to double check and make sure we don't get super confused with the signs, we can just distribute this negative sign. So that becomes negative x squared. This one flips to plus 3x, and then this one flips to minus 2. Now, just like last time, we just look for the highest exponent, and there's a minus x squared. That's not going to combine with anything. Negative 5x's plus 3x's, so negative 5 plus 3 is negative 2x's. And then I got 7 and negative 2, so 7 minus 2 is 5. So I get plus 5. And then we're all set. So again, not too crazy. We just have to be careful with the negative sign that flips everything after it that's in the parentheses. For number 5, it says find the product. So it's good to remember, because again, we're getting into testing season, that product means the same thing as multiply. A lot of people forget that one, and then they'll just miss a question because they didn't remember what the vocab was. So for multiplying, if we've got something out front, we were doing really good with this all year. So we're going to take this and just distribute it to all the pieces. So that we've been really good with. So that's pretty nice. We've been really good with doing negative 7 times negative 2 to get regular 14. But then the thing that people are struggling with is I've got y to the second times y to the fourth. So I'm going to write this out just as a little recap. Y to the second is y times y. So we're going to do those in blue, actually. And y to the fourth is y times y times y times y. And if we count them up, we get 1, 2, 3, 4, 5, 6. So we get y to the sixth. Now again, by shorthand, some people are just adding these numbers up, which is what you can do. But if you aren't sure, again, just write it out. Actually write it out. So we're going to get y to the sixth. For the next one, I got negative 7 y squared times regular y squared. So negative 7 times 1, we can put a 1 there if we want, is not plus, is minus 7. And with the y's, I got y to the 2 times y to the 2. So 2 plus 2 is 4. Minus sign a little bit better. Then I got negative 7 times negative 1 is positive 7. And y to the second, and then there's no y's here, so 2 plus 0 would just give us 2. So that's the idea. That's how we find the product. So it's just distributing for this multiplication. And again, we're going to do some more distributing. So this one we can use the double distributive method. Or if you wanted to do it with the boxes, you could do it with the boxes. I'm going to do it both ways, just to remind everybody who wants to do one way versus the other way. If you want to do it without the boxes, we've got 4x squared times this whole trinomial over here. So 4x squared times x squared minus 3x plus 8. And with the 6, I have to multiply that by the whole trinomial. So plus 6 times x squared minus 3x plus 8. And now I got to do a whole bunch of distributing. So we're going to do all this distributing. 4x squared times x squared is 4x to the fourth. 4x squared times minus 3x. 4 times 3 is 12. X to the 2, and then x to the 1. 2 plus 1 is 3. 4 times 8 is 32. And then x squared just gets to stay as x squared. In blue, we distribute everything again. So it's a whole bunch of distributing if you wanted to do it this way. We get 6x squared. 6 times 3 is 18x. And then 6 times 8, we would get 48. Again, I got that minus sign because that minus sign just kind of travels with it. I'm almost done. I just have to combine all the like terms. I can see I only have one x to the fourth. So only one term with x to the fourth. So it's actually 4x to the fourth. So I'll write that as 4x to the fourth. My x cubes, well, I only got one of those. One term with that. So minus 12x cubed. These two, though, these are both x squareds. So 32 plus 6 is 38 x squared. Minus 18x, we can see we're just kind of cleaning up here. And then plus 48, those aren't going to combine because they have different numbers of x's for their exponents. So if you like doing it with the double distributive property, you can see it doesn't take up too much space, pretty clean, and we're all set. If you want to do it the other way, if you want to do it with the boxes, you can see we've got a binomial times a trinomial. So one of the sides has to be 3 boxes big, the other has to be 2 boxes big. So I just kind of saw it this way, 4x squared and then plus 6, x squared minus 3x plus 8. And we just kind of fill in all of our areas. So 4x squared times x squared is 4x to the 4th. 4x squared times negative 3x is negative 12x. That's where they connect. X to the 3rd. 4x squared times 8 is 32x squared. Then we connect these ones. X squared times 6 is 6x squared. 6 times negative 3x is negative 18x, and then 6 times 8 is going to give us 48. Now look, we got actually all of the exact same things here. So when we go ahead and add up all of these areas, 4x to the 4th minus 12x3 plus 32x2 plus 6x squared minus 18x plus 48, we actually get the exact same answer because we have all of the exact same terms. We get a 4x to the 4th minus 12x to the 3rd, 32x squared and a 6x squared minus 18x, and then plus 48. So we get all of the same stuff. And again, that one actually didn't take up too much space either. So the nice thing about this is there's a lot of different ways to do these types of problems. There's even other ways that I didn't put up on the screen right here that you can do it. And however you want to do it is fine with me. So as long as you can do it, that's what matters. You get a lot of choice here. All right, for number 7, so this one's kind of a little bit long. That's because it's a little bit weird, but it's not too bad because we've done problems like this both in class and for homework. So it says a portrait without its frame has a height 1.5 times its width W in inches. The width of the frame is 4 inches wide all along its perimeter. So label each side with an expression. So it says the portion of the frame is a height 1.5 times its width in inches. So if I look for the width, so the width is going to be this right here because we're just doing the picture itself. So a portrait without the frame has a width W. So that means that the circle is W. All right, it tells us that the height is 1.5 times the width. So the height, which is going to be the triangle here, because that's going to be the height of the picture, is going to be 1.5 times W, because 1.5 times the width. So again, we're dealing with a little bit of generalization. We're going to deal with some abstractions. We don't have perfect numbers here. Then it says the width of the frame, so this is the frame itself, is 4 inches wide all along the perimeter. So that means that this length is going to be 4. This length is going to be 4. This length is going to be 4. And this length is going to be 4. So we got to be really careful just by charting everything out. We're going to make sure we get the right answer. Because now if I look at the square here is going to be this big length. It's a 4 plus a W plus a 4. It's 4W and then 4. So if we want, we could write that as 4 plus W plus 4. That would be a correct answer. I'm going to write it in standard form and combine those 4s to be W plus 8. Likewise, if I wanted to do the apple would be 4 plus the triangle plus 4. So it's 4 plus the triangle here is 1.5 W plus another 4, because again, I've got a top and a bottom. Again, I could leave that as the final answer, but I'm going to make it look a little bit nicer. I'm going to put it in standard form and do 1.5 W plus 8. So we've labeled each side, so that's really good. So we've already got all of those done. So for part B, it says, what's an expression for the area in terms of W. So it just wants to basically just use the area formula. Area of a rectangle is length times width. So it wants the framed portrait. So the framed portrait is going to be the square times the apple. That's going to be the width. Or sorry, that's going to be the length. That's going to be the width. So our area is going to be W plus 8. Oops, I'll put that in blue since that's in blue up there. So again, we want this times this length. I guess I made that the width, so I'm using the length a little bit arbitrarily. And that's it. That's actually all we want to do, because it just says what's an expression for the area in terms of W. So that's it. That's all we have to do is just realize, oh, okay, area is length times width. So if I know what the length is, W plus 8, put that where L is. If I know what the width is, okay, we know that, 1.5 plus 8, W plus 8, we just put that where the W is. Now for C, it says, write your expression in standard form. So I actually don't need the picture anymore. I can just focus here on the equation. So in standard form, what it's telling us to do is to just multiply these two things together and combine the like terms. So if I want, again, I can use the boxes if I want to use the boxes. That's fine. I've only got a 2 by 2 this time, so I get a little bit smaller boxes here. It's going to be W plus 8 times 1.5 W plus 8. When I multiply them, this is 1.5 W squared. 1.5 W times 8 is 8, and half of that is 4, so 12 W. 8 times W is 8 W, and then 8 times 8 is 64. So 1.5 W squared plus 20 W plus 64. Oops, I went one step too quick. I jumped right to the answer. 12W plus 8W plus 64, and then these two do combine. 1.5 W squared plus 20W plus 64. Squared is the highest, which makes sense because that's an area. If we think like square feet or square inches, it makes sense that squared would be the highest. Again, I'm going to do this one two ways. If you didn't like using the boxes, this is where we would take the W and multiply it by everything here. So W times 1.5 W plus 8. Then we would take the 8 and multiply it by all of these. So plus 8, 1.5 W plus 8. When we distribute this time, 1.5 W squared. W times 8 is 8W. 8 times 1.5 is 12, so 12W, and then 8 times 8 is 64. And just like before, we can see these middle terms are going to combine. So if we combine our like terms, 1.5 W squared plus 20W plus 64. So we get the same answer either way. So it doesn't matter which way you do it. And it's kind of nice. This one, this time we see we got the 12 first here, we got the 8 first here. Again, that's because the order of the parentheses doesn't really matter. So you can multiply this one first, you can multiply that one second. It doesn't matter which one's out front. So there we go. That's what we want to do. So we can see it looked really scary, but once we actually interpreted the situation, once we modeled it, it was actually just like the previous one, a little bit shorter. All right, for number 8, we have to find the product. So again, we're multiplying. The intent here is if you remember the special multiplying rules, you can just write down the answer. You square the first one, then it's going to be 3 times 2 is 6, times another 6 is 36, and then 6 squared is 36. So you can just jump right to the answer if you remembered that a minus b squared is equal to a squared minus 2ab plus b squared. So that's it. Now, if you forgot the trick, that's okay. You can actually go the long way. And I think we had this all the way back in Unit 1 even. But you can go the long way. You can write this out as 3y minus 6 times another 3y minus 6. And now, exactly the same as the one we just did. Oops. So we're going to do 3y, parentheses 3y minus 6, and then minus 6, parentheses 3y minus 6. We're going to distribute both pieces. So this is going to be 9y squared minus 18y minus 18y plus 36. And if we combine our two like terms, we can see these are the same. That's why we have the 2 right here, because it accounts for those two always being the same in this special case. 9y squared minus 36y plus 36. So we get the same answer regardless if we do the workout or if we just use the trick and just jump right to the end. All right, for number 9, find the product. Again, there's not a lot of space. That's a good indication this is another special trick, and it is. So if you want, you can jump right to the end. 9x squared minus 4, all set. Again, the special trick there is if it's a plus b times a minus b, we're going to get a squared minus b squared. Now, these ones you may not remember because we did them before break, but we did these ones very recently where we went backwards, where we took the a squared minus b squared and then split it up into 2, because that one's missing the middle x, so we know we got to get the plus and the minus. And in this one, we have that special idea where if we can square root them and they magically become this, then we know that we've got a minus b squared or a plus b squared. So we may have forgotten going one way, so we might be a little bit more familiar going back the other way. But the nice thing about these ones is that they're kind of nice if you forget the trick, because you can always just multiply. I didn't do the boxes, but you can do the boxes if you want. So we can double distribute. It's pretty quick. So 3 times 3x squared, or sorry, 3 times 3 is a 3x. 3x times 3x is 9x squared. 3x times minus 2 is minus 6x. 2 times 3x is positive 6x. 2 times negative 2 is negative 4. And again, for this special trick, the middle terms are always going to cancel out to 0. So we get 9x squared minus 4. So again, it doesn't matter whether you go super fast and just do it with the trick, or whether you take the time to multiply out with either the distributive property or the boxes. Both of them will work out. All right, for number 10, we got another word problem here. So the square picture has a 2-inch frame around it. So kind of like the last one, we can see we've got a 2-inch frame. So last time we had a 4-inch frame, so we made all of these 4. This time we have a 2-inch frame, so we're gonna make all of these 2. So we took care of our 2-inch frame. If the area of the frame alone is 72 inches, so that's kind of weird. That means that if we took the area of just the blue space, like all of this, so not the inside piece, but just the outside blue part, we would get 72 square inches. That's kind of weird to see, but we'd have to kind of condense it, but we'd get 72 square inches. It asks, what's the area of the picture? So it wants to know what this is. So we want to know how many square inches. All right, so we don't have too many hints on this one, but the hints are supposed to kind of come from either doing problems like this, like we've done in class before, or by kind of coming back here and saying, all right, well, wait a second. To do this one, we just kind of multiplied these. So we did circle times the triangle would have given us just the picture, and the square times the apple gave us the area of the frame. So the way to think about this one is if I know the whole area, if I know the area of everything in total, that would be, well, we still don't quite know. We still have some unknowns. So we have to make a call, and the call that we're going to make is to either make this x on the inside or this x on the outside. So since we did one previously where x was on the inside, I'm going to go ahead and make the x just like the w. I'm going to put the x on the inside. Now we know these have to be the same because it's a square. So since it's a square, we know those have to be the same, which means on the outside, I've got 2 plus x plus 2, or x plus 4. 2 plus x plus 2, or we know it's the same, it's going to be x plus 4. So I've labeled my picture. Again, this isn't the only way you could do it. You could also make the big part x, and this would be x minus 4s. But I think the plus sign is going to be a little bit nicer. And then we have to think about it. So the idea here is that the area of the big minus the area of the small is going to be the area of the leftover. Now, that vocab's a little bit strange. That might not be something we've seen before, but I've done enough ACT practice with a lot of the juniors to know that this concept's on the ACT like twice every single test. So I'm going to stick with the ACT language, and then you'll see where everything goes. So area of the big, if we do area of the big, that would be x plus 4 times x plus 4. Minus the area of the small. Well, the small is nice because that's the purple times the purple, so that would just be x times x. And that's kind of why I went ahead and made this part the x plus 4. Equals the area of the leftover, but we know that. The area of the leftover is this in blue, and it told us that that was going to be 72. All right, so this still doesn't look too promising, but we still want to go ahead and we want to try and find out what x is. So we'll kind of keep going here. So I can see these are the same. So if I want, I could use the trick. I could just say that it's going to be x squared plus 8x plus 16. But I'm going to go a little bit slow. I'm just going to get in one more good practice with the distributive property. So 4x plus 4, just again to show that this is pretty much the same as most of the other ones we've been doing. This is going to be x times x for x squared. And this is just going to be 72. So I'm going to drop the units right now since I just want to work with the numbers. We just know that that's 72 square inches. So we got a little bit further. So now we have to distribute x squared plus 4x plus 4x plus 16 minus x squared equals 72. And again, I promised that these would be the same. I promised that we could use a trick on this one, and it works out. But if I'm combining like terms, if I notice, I have an x squared minus an x squared. So those are actually going to cancel out. So this is kind of nice. That means we got 8x plus 16 equals 72. And this equation is completely not scary. So this doesn't look like anything that we've been doing in this section with all the x squareds. This is just a regular old x. So we're going to use our unit 1 skills, and we're just going to get x by itself. So we're going to subtract 16 on both sides to get 8x equals, so let's see, it's going to be 56. We're going to divide both sides by 8 to get x equals 7. Now we got to be careful. 7's not the answer because it asks the question, what is the area of the picture? And we know that the area of the picture was going to be this purple times the purple. So that's going to be x times x. But we found out what that was. That was 7. So the area equals 7 times 7, or 49 square inches. So that one's definitely a long one. So take some thought. And I went through this one with a lot of language, just because there's a lot going on here. But again, this one's very similar to what we did over here. So the concept's very similar to how to set it up as number 7. So you want to focus on that a little bit. That's what we got for number 10. All right. So that kind of takes care of everything that we did before break. So now we're going to do number 11. So 11 says, what's the greatest common factor in terms of the polynomial? So in this case, this is where we just want to see if we can divide everything by a number. Again, Savas wants you to divide by -5. I don't care if you divide by 5 or -5. It's your choice. I'm going to do like Savas, just in case that's how you practiced. So I'm going to divide everything by -5. So -25 divided by -5 is 5y to the third. Oops, I want to do this all in red since we did this all in red in class. We did red first. All right, so then we do 15 divided by negative 5 is minus 3y squared, and then negative 5 divided by negative 5 is plus 1y. Now, I don't have to write the 1 if I don't want to. But after we did the number, we said now we have to look at the letters. They all have a y, so we look for the lowest exponent. So we got 3 versus 2 versus 1. So 1 is the lowest exponent, so we're going to divide these all by y to the first. Oops, I got to put negative 5s under all these. So this is going to be negative 5 y to the first, or just y. So I'm going to drop what I don't need to write. 3 minus 1 is 2. 2 minus 1 is 1, so I don't need to write the 1 there. 1 minus 1 is 0, so I actually don't need to write the y at all. So I've got my expression. Since this one asks what is the greatest common factor, I'm just going to pick this part. So this isn't actually part of the answer. We don't need that. We just need to know what we could divide by. Again, if you want to do regular 5y would also be correct. So I'm going to take that as a correct answer as well. For 12, it says factor out the greatest common factor from the terms of the polynomial. We're doing the exact same thing, except this time we need the whole answer. We can't just use the first part. It's not just what we divide by. So again, we look to see what number we can divide everything by. 2 would work, so would 3, but 6 is the biggest, so we're going to pick 6. So 6 divided by 6 is 1. I'm not going to write the 1 this time. 2x squared, and then 18 divided by 6 is 3. Just like last time, we've got 3, 2, and x to the 1, so we can divide everything by x. So that gives us 6x squared minus 2x plus 3. And that's it. That's the final answer. As was said in class, if we're doing this greatest common factor, again, that's like an undistribute. We're going backwards from the distributive property. If we were to distribute, we would get back to the original. All right, for 13, we got to get the factored form of x squared minus 3x minus 10. Now, again, we know like a few different ways that we could solve this one if we wanted to. If you want to use the chart, most people who are just going pencil and paper were using the chart, so I'm just going to go ahead and do that. Negative 10's over here at the end, so we want to multiply to negative 10. So if we think of some ways to multiply to negative 10, I'm just going to guess 1 and negative 10. If I add those up, I get negative 9, but I want to get to negative 3, so that's not right. All right, that's okay. I'll just try again. Then I'll try 2, because 2 is the next biggest number than 1. So 2 and negative 5, so 2 plus negative 5 is negative 3. That works out, so I got my 2. Since this is a 1, I'm actually done. Answer is going to be x plus 2, x minus 5. So we're all set. All done. That's it. So we have that factored. We've undistributed. If you want to double check again, you could multiply x times x is x squared. 2x and negative 5x is negative 3x. 2 times negative 5 is negative 10. It is possible to build it, but since this is a minus sign, we have to be really careful when we're building it because we have to think about the negatives that we would have with the x's. For 14, kind of the same thing. Again, we did a few of these in class. We said if we've got these y's on the end, we're just going to ignore them and put them in at the end. We're looking for things that multiply to negative 24. So again, I'm just going to be lazy and try 1 and negative 24. If I add those up, I get negative 23, which is not what I want. I'm going to be lazy and just pick 2 next. No reason not to be lazy if you want. You'll get the right answer. So 2 and negative 12, we add those up. We get negative 10, still not right. All right, well, let's be lazy and just pick 3. And you can choose to be lazy or intelligent or a mix of both, but I'm just choosing to be lazy today. 3 times 8, negative 8 would be negative 24. So 3 plus negative 8 is negative 5. And we're looking for negative 2. All right, well, let's continue to be lazy. Let's pick 4 next. So 4 times negative 6 is negative 24. So 4 plus negative 6 is negative 2. and that's the one that we want. Again, since there's a 1x here, since it's just x squared out front, we get to just write the answer. So x plus 4, x minus 6, and don't forget the y's, because we got y squared. We have to remember to put the y's here on the end. There we go. And that's it. We're all set on that one. Again, you can build it, but because this is a minus sign here, it's not the best choice to build, but it is possible if you're careful. All right, for 15, now these numbers look pretty big. So when the numbers look pretty big, the first thing to do is to try and make them smaller to make the numbers more manageable. See if we can divide by something. Here we can divide everything by 6. So we'll just divide everything by 6. So that gives us 2y squared minus y minus 15. All right, so we're kind of in for it. This is kind of the big one. So I'm rolling up my sleeves already. So we know we're going to do some big stuff here. What we're going to do is we have to make the chart again. Well, we don't have to, but we're going to choose to. I'm going to choose to do it that way. And I don't pick negative 15 because this number is no longer 1. This is now 2. So if these two, so if this is not a 1 out here, if there's a number in front here, you have to multiply those two things together. So we have to do 2 times negative 15. For negative 30, and that's actually what we're going to try and multiply to get to. So we're going to multiply to get to negative 30. Now again, I can choose to pick my numbers intelligently, or I can just pick my numbers lazily and just kind of get at it. Today I feel like I just want to get at it. So we're going to do 1 and negative 30. So if I do that, 1 plus negative 30 is negative 29. I'm trying to get negative 1. Not right. All right, well, 2 times negative 15. I mean, that's how I got here anyway, so may as well pick that. 2 times negative 15 is negative 13. Nope, we want to get negative 1. All right, 3 is next. 3 times, that's negative 10. So 3 plus negative 10 is negative 7. Nope. All right, next up would be 4. But 4 doesn't really work. I'd have to pick a decimal, and I'm not going to pick decimals. I could pick negative 7.5, but we don't have any decimals in this class for these, so we're not going to go with that. Then 5 is the next laziest number to pick, so 5 times negative 6. So 5 plus negative 6 is negative 1, and laziness finally pays off. We got it. Again, we might have been intelligent and picked that for the first guess, saved ourselves a little bit of work, but like I said, I was feeling lazy right now. Now, the other problem we have is that this is not the final answer. So we can't just write this as the final answer because we have the 2 out front. So with the 2 out front, now we have to think again, and we have to choose another way to finish up the problem. So this one we were kind of split 50-50 in class. So some people liked then taking our terms that we have here and just doing it algebraically. So 2y squared, and then taking these two numbers we got and making plus 5y minus 6y out of the minus y. And then minus 15 is the other number I've got. So if we do it this way, then we have to look for our greatest common factors. So for our first two terms here, we really don't have anything we can divide the numbers by. 2 and 5 don't have anything in common, so they're relatively prime. So that's just 1. But they both have y, so I'm going to put 1y. 2 divided by 1 is 2. Y squared divided by y is y. 5 divided by 1 is 5. Y divided by y would be 1, so I don't need anything there. Then I have to look at my next two. Again, this one, there actually is a number that we could divide these both by. So we can divide them both by 3, but since they're both negative, more importantly, since this first one is negative, we're going to make it a negative 3. So kind of like back to when we had the option of picking 5 or negative 5 earlier in the review packet. This time we kind of have to pick negative 3, because remember, we have to make our parentheses match in order for this technique to work. Since this was positive 2, I'd have to pick a negative to turn this into a positive, because negative 6 divided by negative 3 is positive 2y. All right, negative 15 divided by negative 3 is positive 5. So these two did not both have y. That's why there's not a y right here. All right, so these two parentheses are the same, so that means that this technique worked. That's the new GCF. That's the new greatest common factor. So that's the first parentheses that's out front. And then 1y minus 3. Again, I could just write y if I want, but I'm going to very explicitly show that that came from right there. And that's our final answer. So if you want to go algebraically, that's how you do it algebraically. But like I said, we were about 50-50 on this one. Other people like doing it with the boxes and then trying to solve the puzzle. So if we do it with the boxes, we've got 2y squared. We've got negative 15, so we put those opposite each other. And then the two numbers that we picked, the 5 and the 6, so 5y and negative 6y, and those two are opposite to each other. So again, we have to kind of play our game. It's easy to win the game, though, if we just go ahead and do our greatest common factor between these two right here. So our greatest common factor between these two is just a y. And then we can just divide to get to the rest of them. So 2y squared divided by y, or what times y would give me 2y squared? Well, that would be 2y. We know we don't want to put 2y here because 2y, if we did 5 divided by 2, we'd get a decimal. Negative 6 divided by 2 is negative 3. Y divided by y would cancel out. And then we've got a negative 3 here, or we've got a 5 here. 5y divided by y is just going to be 5. And if we look up on the top, we've got 2y and a positive 5, so 2y plus 5. And then along the side, we've got, that's not green at all. We've got a y, and then a minus 3 in orange. And that's the exact same answer that we got here. So again, depends on how you want to do it. If you want to do it with the boxes, you can go ahead and do it with the boxes. If you want to do it the long way, not the long way, the algebraic way, you can do it the algebraic way. This is the long way to do one of these problems. This is a very long one to do. And again, you can always double check by multiplying. But that's how we would do number 15. So 15 is kind of like the long one. It uses all the tricks for factoring that make things long, not all the tricks for factoring that makes things short. All right, well, after that, now the rest of the review guide is going to be pretty easy. This one's a trick, so if we look, this is one of our square root ones that we could do, because we know this is going to be x. We know the square root of 81 is going to be 9, and if we check, x times 9 times 2 is 18x, and we have 18x here. So we can just jump right to the answer, x minus 9 squared. Minus, just because there's a minus sign there. Oops, I should probably make these the right colors. X is in red, 9's in blue. All right, so that's it. Again, if you didn't want to use the trick, you're more than welcome to do the table. If we do the table, since there's just a 1x squared here, we actually get a nice one where we just have to pick 81. So we have to multiply to get to 81. And we're trying to add to get to this middle negative 18. So again, we could choose to be lazy. Sure, we'll choose to be lazy again, I guess. So for lazy, what are we picking? 1 and 81, which is 82, so that's not right. Okay, 2 won't work because that's not even, so I'm not going to write down 2. So 3 works out. Oops. 3 times 81 divided by 3 is 27. So 3 times 27. So 3 plus 27 is 30. Still too big, so still no good. 4 doesn't work, not even. 5 doesn't work, doesn't end in a 5 or a 0. 6 doesn't work, not even. 7 might work, but 70, 77, 84, we missed it, so it's not 7. 8 won't work, it's not even, so then we try 9. Again, if you don't want to think about it logically, you can always just type them all in your calculator. 9 times 9 is 81, so that's kind of cool. 9 plus 9 is 18. That's not what we want. We want negative 18, so then we know to flip the signs. All right, and then we can write it out as x minus 9, x minus 9, which is the same thing. So these two are equal to each other. Either answer is correct. Again, we can just jump to the answer. We don't have to do the long stuff that we did before because this is just a 1x squared. All right. For 17, again, there's not a lot of space, so it's a good indication that we're going to do another trick. So just like this one where we could use a trick, this one we can also use a trick. Also, there's a typo here. This is probably has to be an x or a y. Sorry about that. We'll make it an x. So if we square root this, we get x. If we square root this, we get 7. If we check, x times 7 times 2 is not negative 14, it's just 14x. Looking at the negative sign. So that works out. So by virtue of the trick, we get x, we get 7, and we pull our sign from right here. So that's a negative sign. So minus squared. All right. Again, if you want to do the chart, more than welcome to do the chart. We're going to multiply to get to 49. And then we need to add. I'm starting to feel a little less lazy, so I'm just going to go ahead and pick 7 times 7. Let's make a negative 7 times negative 7. Negative 7 plus negative 7 equals negative 14. Got it in 1, so x minus 7. X minus 7 would also be a correct answer. So those two things are equal to each other. All right. For 18, we get another factor. So for some people, this is going to be a tricky one. It is a trick. It is one of the trick ones because we can square root it. Square root of 36 is 6. Square root of y squared is y. Square root of 49 is 7. And since it's missing the middle part, it's missing the one with just the letter without the exponent, we know this is the one where we pick one of each. So we get 1 plus and 1 minus. Doesn't matter the order. You can make the plus first or the minus first. But they're both 6y's. They're both 7s. And that's it. If you wanted to go ahead and use the table, you can. But you have to remember 36y squared plus 0y minus 49. When we make the table, we don't want to pick this 36 at all. And, uh-oh, that's not a 1. That means if we want to do this, we have to do 36 times 49. Well, all right. This one might take a while, because if we have to do 36 times 49, 6 times 9 is 54, 9, 27, 3, 24, 4 times 6 is 24, 12, 14, so we get 1, 7, 6, 4. I need to find things that multiply to 1764 negative and add to 0. Okay, well, it's a good thing that I know my tricks. The answer has to be 42 because 50 squared is 2,500. So 25 minus 8 is 17. 8 squared is 64. 50 minus 8 is 42. Perfect. 42 times negative 42. Add them up. We do get 0. Very easy. If you don't know your tricks, it's going to take a while to use your calculator to get from 1 to 42 because you're going to have to do a lot of guess and check. And the other big problem, this is now a 36. So unfortunately, we got to go the long way. So we got to take the long way on this one. So 36y squared, the 2 that we got here is going to be plus 42y minus 42y, and then minus 49 from all the way up here. Even though we call it the long way, there's not really much thinking we have to do because we know we're just doing a bunch of GCFs. So here, greatest common factor, I can divide them both by 6. They both have y. 36 divided by 6 is 6. 42 divided by 6 is 7. Over here in blue, they're both negative, so I need it to be negative. 42 and 49, we can divide those both by 7. That's going to be 6y minus, plus now. So negative 49 divided by negative 7 is regular 7. Looking good because these are both the same. This is what we want. New GCF, 6y plus 7 is the same, so we put that out front. And then the pieces that are left over, 6y minus 7. Look at that. The long way works. We actually get the same thing. So you could do it that way. Again, probably not the way that you're going to choose to do it, but it is an option. And hey, this trick that I know finally comes in handy. Finally knowing how to square numbers that are close to 50 works out. We got one. All right. Number 19. So just a regular factor. Again, we see the 6 out front. So no tricks on this one. We can't really do square root 6. That doesn't really work out too well. So we're not going to use any tricks on this one. This is just a normal one that's a little bit long. So this one's kind of testing if you remember the full way to do it. No GCF this time, so it's shorter than that other one, but it's just testing that full method. So if we multiply these two numbers, 6 times negative 15, we're going to get negative 90. So if we use our chart, we need to multiply to negative 90. For the plus, we see we got to get 1x. So there's an x right there, so that's a 1x. Now again, if I'm using this intelligently, I know that that's 1. So I know my numbers are going to be pretty close together. But, you know, I expanded a lot of brain power on that last question, so let's just be lazy. Let's pick 1 and negative 90. That's going to give me negative 89. That's no good. All right, 2 next. 2 and negative 45. Negative 43. No good. 3 is next. 3 and negative 30. Negative 27. That's no good. 4 is next. Well, 4 would be 20.5, 22.5. Either way, it's a decimal, so that's out. 5 is next. 5 times, so that's going to be 18. Because 20 would be 100, so step it back 2. So we got 5 plus negative 18 is negative 13. That's still too much. 6, why did I scroll down? 6 is what got us here. So 6 times negative 15. 6 plus negative 15 is negative 9. So we can see how the numbers are getting closer together, and our numbers are getting closer and closer to 1. 7, again, 91 times 7 is 13. That's a fun one to know, but you'd go 70, 77, 84, and then 91. So not 7 doesn't work. 8 doesn't work because 4 didn't work because 4 is a factor of 8. So then we try 9. 9 times 10. So 9 plus negative 10 is negative 1. That's pretty close. But we know at that point to just flip the signs. We finally got the one that worked. And again, kind of like we predicted, because this was the number 1, the 2 numbers that we wanted were just really close together. So we can go then from here. Either way, if we want to go the algebraic route, we would go 6x squared. And then we would split this up into minus 9x and plus 10x. Again, if we added those, we'd get back to 1. Minus 15, GCF it. We can divide them both by 3, and they both have an x, so 2x minus 3. GCF it, we can divide them both by 5. This time, since this is already positive, I don't use a negative sign here. Even though there's a minus here, I'm just looking at this one with the x's. 2x minus 3. New GCF, our parentheses match, which is exactly what we want. 2x minus 3. And then we get 3x is left over, and then 5 is left over. So again, took a while, but that was because we were trying to be lazy with our guesses. So being lazy made it take a long time. But the downside or the upside is we didn't have to think about it too much. Because once you know 1, again, if you wanted to try 5, you just do negative 90 divided by 5 in your calculator. Again, I'll show the boxes too, just because I know we were pretty evenly split. For the boxes, if we want to factor with the area model, 6x squared and minus 15. The numbers we picked were negative 9x and then 10x. So we make it easy on ourselves. We can see that we can divide both of these by 3, and they both have an x. 6x squared divided by 3x is 2x. Negative 9x divided by 3x is negative 3. 10x divided by 2x is 5. Negative 15 divided by negative 3 is 5. Okay, so that works out. So we get 2x minus 3. There we go. Perfect. That's what we want. We got a plus 5, a positive 5 here. That's what we want. And then we got a 3x. That's what we want to. Perfect. All right. So we got the same answer either way. So you can use either method, whichever one you like the best. Again, that one feels like it took a long time. Again, we spent a long time guessing over here, and we did it twice. So there we go. All right. Final one. Last one we got is number 20. And wow, that one looks like it's a tough one too. So we got 8x squared plus 34x plus 21. No square roots. Can't do anything there. Square root of 8 doesn't work. I'd love to divide everything by a number, but I don't see anything I can divide by because this is all evens and this is going to be 3 times 7. So I think we're just stuck. I think we're stuck going the long way again. We got to do 8 times 21. 168. Uh-oh. That's a big number. All right, so we got to multiply to get to 168. Now, 34 is kind of a big number, so I'm thinking my numbers are probably not going to be close together. So I think actually starting out up at 1 might not be the worst idea. I mean, 1's obviously not going to work, but we'll still put it in the chart. We get 169. 2, so 168 divided by 2 is 84. So 2 plus 84 is 86. Again, remember, we're going for 34. But we can see we're getting pretty close already. 3, does 3 work? Yeah, 3 is going to work. All right. So let's divide by 3. So 16 divided by 3 is 5, and then 1 left over, and then we get 18. So 18 divided by 3 is 6. Oh, that's no good either. All right, 4 is going to work. I think 4 is going to work. 16 divided by 4 is 4. 8 divided by 4 is 2. Hey, we're getting pretty close. Now we're in the 40s. 5 doesn't end in 0 or 5, so that doesn't work. 6 will work because 2 and 3 worked. So let's see. So 16 divided by 6, we could get to 12. So 2 times 6 is 12. We'd have 4 left over. 4 and 8 is 8. So 6 plus 28 is in fact 34. That's what we want. All right. So again, our numbers were kind of far away. If we started here, we could see, oh wait, 8 and 21 is 29. So that's pretty close. So we know that we want our numbers to be close to 8, but a little bit lower than 8. So we could actually start from the beginning and do some guess and check work to cut down on our work here. But again, that's up to you. It's easy to go lazy style. From here, again, we can go either algebraic or with the boxes. Let's just go algebraic first again. So we're starting with 8x squared. We got 6 and 28, so plus 6x plus 28x. And we got 21 over here. We can turn our brains off some more, just like we could over here when we're just guessing and checking, starting from 1. Not a bad plan to save our brain power for some other things. But this is going to be 2 is our greatest common factor. And we can divide them both by x. So 8 divided by 2 is 4. X squared divided by x is x. 6x divided by 2x is 3. And we're going to hope that we get the same thing over here. We can divide these both by 7. That's a good thing we save our brain power for, is for these GCFs, actually. 28 divided by 7 is 4x. Perfect. 21 divided by 7 is 3. Perfect. Looks like we're in business. 4x plus 3 is our new GCF. That's the same in both parts. And the leftovers, 2x and 7. All right, if we want to use the boxes. For our area model, we got 8x squared. We got a 21. And then we split this 34 up into 6 and 28. So 6x and 28x. So again, I think what the greatest common factor is here, I can divide those both by 2. I can't pick 3 because that doesn't work here. 4 doesn't work here. 5 doesn't work anywhere. 6 doesn't work here. So yeah, it's got to be 2. They both have the x. 8x squared divided by 2x, oops, wrong color, is going to be 4x. 6x divided by 2x is 3x. 28x divided by 4x is 7. And 21 divided by, ooh, almost messed up. Good thing we double checked. 21 divided by 3 is 7. Yeah, 6x divided by 2x, yeah, the x would cancel out. Okay. Along top, we got 4x plus 3. Along the side, we got a positive 7, and we got a 2x, and we got them to be the same. So there we go. So we got it. All right, and that's actually it. So we're all done with the study guide, and I didn't even have to go to Desmos once there. That was kind of strange. We did it all without the calculator. Now on the test, obviously, if you want to use the calculator, go for it. Calculator is very handy because you can use the calculator to do some of the scratch work. The other thing that some people noticed is the calculator you can actually use to double check your work. So if we had this one right here, so 8x squared plus 34x plus 21. So if we go to Desmos, let's bring that up. 8x squared, I'm not in nice mode. And I haven't gone to Desmos for a while. I already forgot the equation. Plus 34x plus 21. We can see we get this parabola. Again, we can zoom out to make the parabola look a little bit nicer, but yeah, we get a parabola here. If we type in our answer that we got, for parentheses 4x plus 3, and then 2x plus 7, so parentheses 2x plus 7, kind of like we did when we were looking at our systems of equations, if these two are exactly overlapping, that means that they're the exact same. So that's how I know that I got it right. So the graph itself is a little built-in self-check. So if you graph what you started with and you graph what you ended with, if you graph the answer, if they overlap, they're the same. If they're equal to each other, well, that's the whole goal, right? We wanted to turn our sum into our product, or vice versa. If you want to use some multiplication, you could multiply your product back into a sum. You can double check it with the graph. So it's a little handy thing that some people did pick up on. If you watch the video, obviously you know it now, but this is going to get into some of the stuff that we're going to do very shortly. So it's a little preview, but it's also a big help on this test, just in case you see anything that you want to double check, or if there's any multiple choice, you want to double check some answer choices, you can always do it with the graph. So that's everything for this one. Again, it's another big one, but I think we're going to do pretty good.